Okay, so here you have a sphere which is generated by revolving x squared plus y squared equals 9 around the y-axis. You've got water forming a puddle with some depth d, and you're basically trying to find the volume of this puddle, which basically is just a section of the sphere at the bottom. So because you're rotating it around the y-axis, then it would make sense to just take a section like this, take a slice like that. And so we're basically trying to work out the integral. The volume will generally be pi times the integral. You want to work out what the, I guess, the lowest y value is to the highest y value is. And so we know that because it's x squared plus y squared equals 9, that this would be 3. Because this distance here is d, then that would suggest that this is, well, -3, I suppose. So if that's -3, that will become -3 plus d. And so we're basically taking the integral from -3 to -3 plus d. And then we're going to basically take this, well, x squared dy. Okay, so it's pi, the integral from a to b of x squared dy. Because x squared plus y squared equals 9, we can quite easily get x squared just equals 9 minus y squared. So that should be a fairly simple integral to do. It's a standard integral, so it's 9y minus 1/3 y cubed. We'll sub in -3 plus d and -3. That's going to be pi 9 times -3 plus d minus 1/3 -3 plus d all cubed minus 9 times -3 minus 1/3 of -3 all cubed. So we'll just quickly see, they want d minus 3 and d minus 3. So let's just, okay, so that is 9d minus 3. So yep, and we've got 1/3. Okay, they took out the 1/3. So let's take out the 1/3. So if we take out the 1/3, that gives us very clearly at the start 27d minus 3 minus 1/3, which has been taken out. So that's now just minus d minus 3 all cubed. Now we've taken out, so this is minus, let's just quickly work out what this is. This is -27 in the brackets. That's -27, that's going to be +9. So -27 plus 9 is -18. Minus -18 is +18. And then because you took out a third is +54. And that's what they want. You can use the calculator work for that. Okay. So therefore, that's part 1. All right, 2. Show that the surface area of the top of the puddle is given by S equals pi 6d minus d squared. Well, if it's the surface area at the top, then it's really just a circle. So we want to find the surface area of the top of the puddle. Now, it's really just a circle though. So really, you just need to find out, given that if you think about the fact that it's sort of revolved around the y-axis, it's really just a circle, and you just need to find pi r squared. So you need to just basically find r. Now, this really comes down to a geometry question now, I think, because if you take a look at the construction, you know that this distance is d. And basically, you're trying to find this distance. You're trying to find this radius, r. Right? If you find that radius r, then pi r squared will do it. So that r clearly depends on d, right? Because if d is 0, then, well, there is no radius, there is no water. And if d is 3, then it will just equal 3, right? Because it's the radius of the circle. So it does depend on d. So you just need to basically draw out the triangle. And the thing with most of these questions is the construction you're often going for involves a construction line going from the center of the circle to here. So you want, this is r. This is r. This is -3. Well, the distance is 3 minus d. The distance is 3 minus d. And this distance is the radius of the circle, which is 3. Which means we're really looking at a right angle triangle scenario where this is 3, and this is r, and this is 3 minus d. And we're trying to find r squared because we're trying to find pi r squared, right? And we're trying to find r squared. So r squared must equal 3 squared minus 3 minus d all squared, which is 9 minus 6d plus d squared, which appears to be 6d minus d squared. And therefore, your s equals pi r squared is as required. And that's how you do it. Make sense?
Yeah.